All right, so the last thing that we got to take a look at here in terms of shapes and molecules and all that type of stuff is what's called polarity. Polarity is a description of when there's there's unequal sharing. Okay, so let's just kind of, I mean, this is as simple as this. I mean, let's say we have atom A and atom B. Okay, atom A, atom B. And obviously there's a shared pair of electrons. A had one, B had one. And there's a shared pair of electrons. Well, those electrons may not be smack dab in the middle of the bonding. What I mean by that is one of those, either A or B, might be a little more attracted to electrons than the other one. Okay? Not every atom has the same attraction or affinity for electrons. So let's say that the electrons are more attracted by B. Well, if that's the case, then the electrons are going to be a little bit closer, let's say, to B. What that does is they're still being shared by A. A still has the electrons being shared. There's still that bond in between, but it's not a complete negative charge, right? If B would be gaining an electron to be a negative charge, and A would be positive, it's a complete gain of electrons or loss of electrons. But rather we have electrons being a little too close, so it creates a partial negative charge when they're closer to the negative, and a partial positive charge when they're further away from something. So it's almost like it's lost, it's almost like it's gaining. Okay? So those are the partial charges. Now, how does this happen? Well, polarity happens because the sharing is unequal, and it more specifically happens because of differences in electronegativity. An electronegativity is how strong the atom pulls the electrons, how much that atom wants to have an electron. Okay? And so if one pulls harder than the other, then there's going to be unequal sharing. If there's equal pull in each direction, then we would have a non-polar molecule. Now, there's a chart in your book, page 177. Please take a look at it there, and that's where you're going to use it. You can obviously use the internet and type in electronegativities. But here's the differences. If we have less than or equal to 0.4, then that means it's a non-polar sharing or non-polar bond. Okay, so for example, if we have two hydrogens, well, obviously each hydrogen is going to pull equally. So there's going to be a zero difference in electronegativiity. We're looking at differences in electronegativities. And so since they're the same, both hydrogens, and I should probably different color. Hydrogen is 2.1, hydrogen is 2.1. Obviously the difference is 0. So that means that the pull in either direction is the same, non-polar. And it goes up to 0.4. So if it's 0.4, then it's non-polar. If your pull gets between 0.5 and 1.9, then it is polar. It's polar and being pulled towards whichever one is higher. Okay? So another example, and I'll show you these are, but another example of a polar one would be hydrogen and oxygen. I'm not going to put it together with the whole correct structure, but hydrogen is a 2.1, oxygen is a 3.5. So that's a 1.4 difference. Since it's a 1.4 difference, that is in between and it is polar, and so therefore it would be pulling towards the oxygen. The way that we represent if there's any kind of polarity is we draw an arrow towards the one that's pulling harder, towards the oxygen. And then we put a little line through it. So it's an arrow with a dash through it. What that dash represents is it's pulling more towards the oxygen, but it's still being held on to by the hydrogen. Okay? If we have a difference in electronegativity of greater than 2.0, then that means there's so much pull that it actually gains the electron and the other one loses it, and we'd have an ionic compound. Okay? Here's a list of electronegativities. You certainly don't have to know these. I don't know them all, but use the 177 in your book or use the internet for these different electronegativities. I'm going to show you how we can do this again here on another example. Let's say we have the example of CH3NO. It'll be a good little review to put this one together as well. So let's go ahead and put this thing together. Carbon has 4 electrons. Hydrogen has 1. 3 hydrogens. Nitrogen has 5. And oxygen has 6. All right, so we have 4 available here, 1 on each on the hydrogen, 3 available here, and 2 available on the oxygen. Well, how they're going to get together? Well, the fact that these 3 hydrogens are written near the carbons will kind of allow us for this 3 hydrogens on the carbon. I have now 1 available on the carbon, 3 available on the nitrogen, and 2 available on the oxygen. Hopefully we're seeing that if I get a carbon and a nitrogen together, I think I've been moving around. If I get a carbon and a nitrogen together, that leaves 2 left on nitrogen and 2 left on oxygen. Bond and bond. We'd have a double bond. Let's clean it up. Carbon has 1, 2, 3 hydrogens. And it's bonded to a nitrogen, which is double bonded to an oxygen. Now this isn't perfectly cleaned up because I should recognize my central atoms, what's it doing, what geometrical shape. Here's a central atom. Carbon has how many coming off? Well, it has 4. 1, 2, 3, and the nitrogen. So that's 4 coming off of that one. I'll circle. Okay? So carbon with 4 coming off, that's a tetrahedral. So let's draw that with 4. 1. Actually, let's do it this way here. Okay? There. 2 in the same plane, 1 coming out at you, 1 going behind. So hydrogen, 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 nitrogen there. Now my other central atom is the nitrogen. It has 1, 2 coming off. Choices when you have 2 coming off are either going to be linear or bent. Because we have the unsharing pair, it's going to bend. And so my double bonding O kind of comes down like this. So that's what this molecule should be. So we basically have a tetrahedral and a bent. I'm going to defer, and what you would call this would be just a tetrahedral. We're going to defer to the one that has more. So a tetrahedral shape. How does electronegativity deal and polarity? Well, let's take a look at the differences. I'm going to erase this if you don't mind. And we're going to now take a look at our differences in electronegativities. Okay, so yellow here. Okay. Between hydrogen and carbon, we've got 3 of them, but hydrogen is a 2.1, here it is, and carbon is a 2.5. That's a difference of 0.4. If you remember, less than or equal to 0.4, non-polar, don't do a thing. Equal pretty much sharing, so don't do a thing. Don't put any arrows. Carbon and nitrogen is another bond. So right, I basically took care of these. But now let's take a look at the carbon and nitrogen. Well, carbon has a 2.5, nitrogen has a 3.0. So that difference is 0.5. Well, 0.5 to 1.9 is polar. So it fits in there. Which one's stronger? Well, the nitrogen is. So we're going to put a little arrow towards the nitrogen. Now we'll look at the nitrogen and oxygen. The double bond doesn't do a darn thing for us. Oxygen is 3.5. So again, we have a 0.5 difference towards the oxygen this time, and there you are. You're pulling more towards the oxygen. I will also mention these are partial charges. The way that we represent partial charges is with the lowercase d, delta, lowercase delta. It looks like a funny little, so partial positive, partial negative. That's what these little funny looking D's look like. So if you want, and you certainly could do that, add a partial negative to this oxygen, because that's the one that's partially negative, it's being pulled. This nitrogen is partially positive, but it's also partially negative because this carbon is not pulling as much as the nitrogen. So here would be a really nice drawing of CH3NO with the whole perfectly drawn shape along with polarity.